Hi, my name is Jeff Willington, and I'm a Technical Product Manager with the Networking and Security Business Unit at VMware. Today, we're actually going to talk about Micro-segmentation Solutions with VMware NSX. As we talk about what NSX provides in terms of security-based solutions for micro-segmentation, let's talk about the security pillar within NSX that actually comprises of all the different use cases that we can actually accomplish. If you see over here on this side of the board, we have micro-segmentation, and this is the concept that we're going to talk about right now. The next section we'll be talking about secure and user computing, and the next section we'll be talking about DMZ Anywhere. In this section, what we're going to do now is we're going to talk a little bit about traditional data center environments and the reasons why micro-segmentation actually provide a much more granular solution for securing data center workloads and securing east-west traffic within the data center. As we take a look over here and we see kind of a traditional style of a security-based approach for a data center. We have a large perimeter firewall, and inside we have our application servers running within the environment. The perimeter-based firewall is not to say that it's a bad thing, but it actually does a really, really good job of keeping things outside of the environment from coming in and allowing things internally to go out as necessary. The problem is that if you see here, this firewall is trying to provide firewalling services for all of these objects within the data center. And while it does a pretty good job, the communications that actually happen internally between these applications is pretty much unprotected. If you try to take a traditional approach and say put in physical firewalls between these applications, what you end up having is you end up having to control multiple different firewall systems. The security posture becomes extremely brittle because as you add more applications to the environment, you have to add more firewall rule sets and have to figure out which applications talk to which ones, and it becomes a very, very operationally difficult job for our security administrators to actually provide that security. Plus, not to mention that it's extremely cost inefficient because we have to provide another physical firewall which can cost tens to hundreds of thousands of dollars per device. So how does all this work? How does this environment work? We have our user that connects in through our firewall. And once they connect into the firewall, they connect to their application. So let's show why this type of layout or this traditional style of security approach is infeasible. Our user logs into the environment and gets into the application. The problem is that our applications within our environment typically have the ability to talk to any other application within the infrastructure as well. Now, this user may only need to talk to the HR application. Right? Say this is an HR user attempting to talk to the HR application, that's fine. But this HR person could also talk to an engineering application as well. And that's something that we don't necessarily want to have access to because we only want the access that we need for those people to connect to the services they require, only those services to be the ones that are necessary. With that in mind, what if this person here actually becomes malicious? Maybe this person turns into someone we don't want in our environment actually accessing our systems. With no firewall protection between these systems, or physical firewall protection between these systems where it's impossible to really know if all the firewall rules that are allowing traffic or disallowing traffic are actually in place, this person who was an HR person before, who is now our malicious attacker, could still gain access to the HR system, but not only that, but could then hop over and access other systems within the environment. So no longer is our HR application the one that's exposed, but our other applications in our environment can become exposed too. So if you think about this, and we expand out our application, this HR application might consist of a web app and a DB tier, But the reason why they're able to traverse these is because we have no security controls between any of these desktop systems. They could compromise the web server and then hop to the next web server and compromise it, hop to the application server, compromise it, and so forth and so on. So how do we take this approach that is very infeasible to do with, say, physical devices, and how do we provide this least privilege model, if you will, network least privilege, so that if an attacker does get through our security perimeter, is only able to compromise a minimal amount of systems that are within our infrastructure and not allowed to hop between other applications that have nothing to do with the application that was actually being the one accessed. So let's take a look at that and figure out let's see how NSX can help with that. With NSX, we have the same style of security architecture we have here. We have this perimeter firewall, and we have our application servers as we typically do within our environment. But what we're going to do is, these communications are still going to happen, but each one of these different applications, we're going to take our app and break it down into its web, app, and DB, similar to what we did before. And we're actually going to create policies that state that the web systems can talk to the app systems and the app can talk to the DB systems only over the ports and protocols that they need to talk to. So how do we do that? These virtual workloads, we're going to put a firewall, a stateful firewall, at the VNIC of every one of these virtual machines. Which means every firewall, if you think about this in physical terms, you have a switch and you have a physical server. The network connection between the server and the switch, we're putting a firewall right in the middle of that. Which means now we're able to provide granular control over every component of this application and control how these systems talk to each other. So we can say that our web servers can talk to our app servers over, say, 8443, and our app talks to our database server over, say, something like 3306 for MySQL. And our web servers accept traffic only on 8443. That means that anyone that comes into and attempts to connect to this application, attempts to connect to our web servers, if they're connecting on any other port other than 8443, that connection will be blocked. This means no port 80 or any other ports of that nature. So let's go back and take a look a little bit about how we're actually able to accomplish this. So this application is going to run on a host. So we're taking the vSphere hypervisor that runs on a physical host, ESXi, and it has the distributed switch that runs on top of that. This switch is what our virtual machines connect into, and in that host, we're going to provide the virtual machines with what we refer to as the distributed firewall. This distributed firewall is a kernel module that runs inside the ESXi hypervisor and provides line rate performance or near line rate performance for the firewalling capabilities for our virtual machines. Which means as our virtual machines talk to another virtual machine, even if it's on the same server, they talk through the distributed firewall and we can control the traffic regardless of where the system actually sits within the environment. We're going to put our firewall here, and now if we don't want two virtual machines to talk to each other, we can actually say these two virtual machines are not allowed to talk to each other. So let's go back for a second and think about how we're able to, let's go back to our attacker here that's coming through. If we have our HR application here and we see that we have two web servers, an application server, and a database server. If this is the way that these systems actually function, we don't want our web servers to talk to each other. So with NSX, we can actually provide and say that web-to-web communications are not allowed. Very, very simply, by taking NSX, putting a security group around our web servers and saying our web servers can no longer talk to our web servers. This is something that they don't need to do technically, because our web servers only should be talking to our application servers. So our attacker over here, who is able to compromise, say, one of our web servers and then continually move to the next web server, won't be able to do that because these two servers were never allowed to talk to in the first place. What we're also going to do is we're going to say that web can talk to app, but only over 8443. This means any other port and protocol that anyone tries to connect to from the web to app servers is no longer going to be allowed. This means if this attacker comes through and does indeed compromise one of our web servers, that they only have the attack surface of being able to leverage this port to perform their attack on. Let's take this a little step further. We're going to say our app to database system can talk over 3306. Same concept. If we attempt to have our app server connect to anything other than 3306 to our database server, it's not going to be allowed. If we don't, and then the last rule here is we would say that we would block all rest of the traffic, which means that our web servers would not be able to talk to our database server, and our database server wouldn't be able to talk to any other servers within the actual application. This is how NSX provides a very, very secure intra-data center firewalling and security posture that a traditional style of security posture with physical devices or not having anything in here at all is not able to provide. In our next section, we're going to be talking about using these same technologies and these same kinds of concepts and leveraging them to secure end-user computing environments with NSX. Thanks for watching.